Good afternoon, folks. How are you today? This is our last lecture. Before I begin, uh, only two of you have filled in this S-rate course evaluations. Would you please log in to smartevals.com and fill out the course evaluation? It might take you just a few minutes. Thank you. I'm not going to be teaching anything new. I just want to give you an overview of what you have learned in this course, what you have accomplished in this course. So now, after having finished the course, you should be able to solve one nonlinear equation. In fact, you saw that we use secant method in a variety of different ways. We use Newton's method in a variety of ways later on. Then we learned how to solve a system of linear equations. With these two capabilities, we combined these two ideas and were able to solve a system of nonlinear equations where we had n equations in n unknowns and all of them were nonlinear equations. We used the idea of linear equations to set up how we can do curve fitting by combining it with least squares criteria. So now you can fit both linearized fitting curves as well as non-linear curves. Then we went on to learn integration techniques. So now we can integrate even functions that cannot be analytically integrated. So I gave you several examples. In the past, when computers were not available, we often had to look up these table of integral values in handbooks. But now you can just do it on your calculator, or if you have access to Excel, even better. In addition to integration, we also learn numerical differentiation. So now once we know integration and differentiation techniques, we can combine them. In fact, we use integration techniques to solve a first order differential equation. Then we combined this idea and with matrix algebra. In fact, we didn't use matrix algebra, we just stuck to two equations only. But in principle, we could use matrix algebra and solve a system of first order differential equations. We use this idea of system of first order differential equations to then solve one second order differential equation, an initial value problem. And now that you know it, you should be able to solve, in fact, a system of second order equations, in fact, any order equations. And finally, we learned how to solve a boundary value problem. That was our the lecture before this. So you learned a lot. So I hope you reflect on it. And as I was thinking along, you also learned how to implement these methods, how to solve them very easily and effectively with great precision. So even though my first lab, I just did not pick up an applied problem, I just picked up an equation, simply because here I wanted you to get the big picture of Excel, how to set up a spreadsheet in a professional manner, and so on and so forth. So my first two labs just used a simple function. But from then on, I wanted to give you an applied flavor. So you may see that most of the rest of the labs had applied problems that I picked up from variety of things. Realize that I'm very limited. I cannot pick up very intricate technical problems because of prerequisites and such. So then in our lab 3, you solved a real practical problem. It was a geometric problem of water in a spherical trough. Then we learned some matrix operations, how to do linear algebra with Excel. And then again, I gave a very simple example, but in principle, you can use this Gauss-Seidel method to solve large system of size millions, if you like. Again, another applied problem in solving a nonlinear system. So you will see problems like this in soil mechanics, in solid mechanics, and in fluid mechanics. So you will see these kind of problems. Then we did curve fitting, linear curve fitting, nonlinear curve fitting. And of course, I am sure you know that you can use these techniques in your projects, in your other labs, and I hope you do. Another problem I picked up was this length of corrugated roof, which required integration, numerical integration. And then I showed you this 4-bar linkage. And I don't know if you realize it or not, about 40 years ago, when computers were not easily available, this would have been a whole master's thesis, something that you just did in one lab. Here is first order ODE. You'll be coming across ordinary differential equations in your other courses, I hope, in your upper level tech electives. So again, there you will have a chance to solve more complex problems, and you can use these techniques. Second order ODE, I picked up a problem from dynamics. I hope you enjoyed it. And this Monday, we are going to do Lab 14, which should be a heat dissipation problem. So if some of you have taken a heat transfer course, I hope you enjoy it. So, all right, so we did 12 labs and you learned to solve a variety of problems. Now, often in my surveys, etc., people mention about quizzes, and I really want you to appreciate after doing 3 attempts at each quiz, you really did learn the material. Some of you may have tried to guess the answers, but most of you, I think, learned the material, and it is reflected on the test. I give you 36 questions on a 50-minute test, and the median score is 85%. And I hope through this you have also learned how to be efficient in using your calculator. So that was one of my other objectives. So in conclusion, I think you have learned a lot. I think you have accomplished a lot. I hope you reflect on it. And I hope you find ways to use this material that you have learned in your other courses. Okay, just to wrap up, we have a final exam coming after the Thanksgiving break, but we have a review before the Thanksgiving break. The final exam is on Tuesday, 4:15 to 6:15. That is December 1. Online, synchronous. It is comprehensive. It is same length and format as the previous 2 tests that you have taken. So very similar to what you have done before. I have posted test 3 formula equation sheet on my courses. And this Friday, we are going to have a review on Zoom. Please bring your problems and I will be happy to solve them. It's a synchronous session from 3:35 to 4:25. I'll really appreciate if you will have your video on. Thank you. Again, I want to appreciate. I want to again ask you to fill out the course evaluation. I really appreciate your feedback. Thank you. Should be having great summer. Have a great Christmas. Thank you.